Hello dear students, I hope you are enjoying the lectures of permutations and combination. Students, in our last lecture, we had studied till permutation. We had understood the meaning of the word permutation or arrangement of objects. Now, I will take up a few more examples and understand the word permutation in somewhat deep. And then we will move forward and understand what is the meaning of the word combination. What is the formula of combination of n distinct objects taken R at a time. Alright, so let's get started with the topic. So this question says, find the number of permutations of the letters of the word Allahabad. So we have a word Allahabad in which we have 4 A's, 2 L's, and apart from these we have one H, one B and one D. So in all we have 9 letters in this given word. So these 9 letters can be arranged in how many ways? They can be arranged in 9 factorial divided by 4 factorial multiplied by 2 factorial. Alright. Why? Because these 4 A's are of similar kind and these 2 L's are of similar kind. They are repeating, so that is why we have divided over here with 4 factorial and 2 factorial. Now we can do further calculation. 9 multiplied by 8, 7, 6, 5 and 4 factorial, and this is divided by 4 factorial multiplied by 2 factorial. So 4 factorial gets cancelled off and 2 divides 8 and gives us 4. So upon calculation the total answer comes out to be 7560. So the total number of permutations that can be made out of the letters of this word are 7560. Alright, I hope everybody understood this problem. Let's take up next problem. Next problem says, how many 4-digit numbers can be formed using the digits 1 to 9? So we have digits from 1 to 9 and out of these digits we have to form 4 digits number if repetition of digits is not allowed. So students, please make a note that repetition of digits is not allowed. So we have been simply asked that how many 4-digit numbers can be formed or made if we have digits from 1 to 9. So in all I have 9 digits and out of these 9 I have to permute or arrange 4 digits. So this can be done in how many ways? Simply 9p 4 ways. According to the formula of NPR, this can be written as 9 factorial divided by 9 minus 4 factorial, because we know that NPR is equal to n factorial divided by n minus r factorial. So this turns out to be 9 factorial divided by 5 factorial, which can be further written as 9 multiplied by 8 and 7, 6 multiplied by 5 factorial whole divided by 5 factorial. So again 5 factorial gets cancelled off and the rest part is calculation, that is multiplication of 9, 8, 7 and 6, and upon multiplication we can get the answer as 3024. So in all 3024 numbers can be formed with the digits 1 to 9. Well, the next problem consists of 4 different parts. Let us check one by one. First of all, let's read the problem. Find the number of arrangements of the letters of the word independence. In how many of these arrangements? First part says, do the words start with P? So first of all, we have been given a word independence. Alright, I have written it down in such a way so that we can calculate different type of letters in this word that are being repeated or not. So we have 1, 2, 3, 4 E's and then 1, 2, 3 N's Alright, then we have an I, 2 D's, 1 P and 1 C. So in all we have 4 plus 3 7 plus 2 9 10 11 and 12. So there are total 12 letters in this word, out of which 4 letters are alike of one kind, 3 letters are alike of another kind, 2 letters are alike of another kind, and remaining 3 are different. Alright, so we have segregated the letters of this word independence. Alright, so let's get started with the demand of question. Even before the first part, we have been asked find the number of arrangements of the letters of this word. So in how many ways we can arrange the letters of this word? This can be done in 12 factorial whole divided by 4 factorial multiplied by 3 factorial multiplied by 2 factorial. Alright, why? Because in all we have 12 letters, and out of these 12, 4 are alike, 3 are alike of another, and 2 are alike of another kind. Alright, so you can do the calculation in this part and arrive to the answer as 1663200. Alright, now let's begin with the first part of this question. First part says, in how many of these arrangements do the words start with P? So the demand of first part is, in how many of these words we can start with P? So the first place in this 12 lettered word, 1 2 3 4 5 6 7 8 9 10 11 and 12. So in this 12 lettered word, the first place is already occupied by P because it is in the demand of question. Now for remaining these places, that is remaining 11 places, there is no such restriction. So for remaining 11 places, we can make arrangement in how many ways? 11 factorial divided by, now P is gone, so we are left with 4 E's, 3 N's and 2 D's, and because of this we have to divide it with 2 factorial, 3 factorial and 4 factorial. Alright, so in this part we have written 11 factorial divided by 2 factorial into 3 factorial into 4 factorial, and upon calculation the net answer comes out to be 138600. Alright, let's move to see the second part. Second part says, in how many of these arrangements do all the vowels occur together? Now the demand of second part of this question is that in how many of the arrangements do all the vowels occur together? So how many vowels do we have? We have 4 E's and 1 I. So we have E, E, E and one more E, and then we have N, I. These are the vowels in the word independence. And apart from these 4 E's and this I, we have 3 N's, 2 D's, 1 C and 1 P. Alright, but this part says that vowels must occur together. So what I will do, I will keep all these vowels in a box. Alright, we have kept all the vowels in a box. Why? Because we want vowels to always occur together. Now consider that we have 3 N's, 2 D's, 1 C, 1 P, and this entire box will be considered as one unit or one letter. So total we have 3 plus 2 plus 1 plus 1, which gives us 7, and over here I have one letter in all. So total we have now 8 letters, and these 8 letters can be arranged in how many ways? 8 factorial divided by, because of these 3 we have to divide it with 3 factorial, because of these 2 we have to divide it with 2 factorial. Alright, so up till now we have arranged these 8 letters or these 8 units. But when I have considered this box as 1 unit or 1 letter, inside this box also one must understand that there are 4 E's and 1 I. Total there are 5 letters. Now these 5 letters can also be arranged among themselves in how many ways? 5 factorial divided by 4 factorial. Alright, first of all, what we did? We considered this all together as 1 unit or 1 letter. So total there were 8 letters. 8 letters were arranged in how many ways? 8 factorial divided by 3 factorial multiplied by 2 factorial. And then we have further multiplied this quantity with 5 factorial divided by 4 factorial. Why? Because this indicates internal arrangement. The arrangement inside this box. And this entire indicates total arrangements. Alright, so this is the method of second part, which is called as box method, and the answer upon calculation comes out to be 16800. Alright, let's move to see our third part. Third part of the question says, in how many of these arrangements do the vowels never occur together? Alright, now since we want vowels to never occur together, what I am going to do is, I am going to calculate total number of arrangements. Alright, we are going to calculate total number of arrangements, and out of these total number of arrangements, we are going to subtract the number of arrangements in which vowels occur together. Alright, what I am trying to do is, I am first trying to calculate the total number of arrangements of the letters of the word independence, and out of these total number of arrangements, we are going to subtract the number of arrangements in which vowels occur together. So what you are going to get? You are going to get the total number of arrangements in which vowels never occur together. Alright, now total number of arrangements have been already calculated by us over here. That is 1663200. And number of arrangements in which vowels occur together has been done by us in which part? Second part. And the answer corresponding to it is 16800. So we have to subtract 16800 because we have already calculated the total number of arrangements as well as number of arrangements in which vowels occur together. So upon subtraction, the answer comes out to be 1646400. Alright, fourth part says, in how many of these arrangements do the words begin with I and end in P? Alright, do the words begin with I and end in P? Now, for fourth part, we have been given restriction that we have to form total number of arrangements in which the first place is occupied by I and the last place is occupied by P. Alright, that is, the word has to start with I and end at P. So since the places of I and P have been fixed, we are left with total 10 places. And at these 10 places, we have to arrange the remaining letters. So the remaining letters can be arranged at these 10 places in how many ways? 10 factorial divided by 3 factorial, 2 factorial and 4 factorial. Alright, so Upon calculation, this comes out to be 12600. So this is the answer of fourth part of this question. Let's see our next question. Next question says, find the number of words with or without meaning which can be made using all the letters of the word again. So we have been given a word again. If these words are written as in a dictionary, what will be the 50th word? Now first of all, we have been asked find the number of words which can be made using all the letters of this word. So in this word we have 2 A's, 1 G, 1 I and 1 N. So total we have 2, 3, 4 and 5 letters. 5 letters can be arranged in how many ways? 5 factorial divided by 2 factorial, because we have 2 A's which are of same kind. Alright, so this is equal to 5 into 4 into 3 multiplied by 2 factorial and divided by 2 factorial. So the answer is 60. The total number of words with or without meanings that can be formed using all the letters of this word again is equal to 60. Now in the subsequent part we have been asked if these words are written in a dictionary, what will be the 50th word? Now we have to form a dictionary in which we have to use only these letters A's, G, I and N. And in that dictionary, what will be the word that will be present at 50th position? This is the demand of the question. On the basis of our common sense, we can simply say that any dictionary having these letters only will start with the letter A first. That is, first place is always occupied with letter A. And then we are left with 4 places. Because in this word again we have total 5 letters. So first letter A has already occupied first place. So now we have 4 vacant places. So the remaining 4 places can be filled up in how many ways? They can be filled up in 4 factorial ways. And 4 factorial is equal to 24. Alright, so we are done with the words that will be formed when they start with A. Total 24 such words will be there. But we have been asked about the position of 50th word. So we are going to continue with our calculation even further. Now in dictionary, what letter may come after A? The second letter that is going to be at first place is G. Alright, after A there will be G in the dictionary. Now again I have 4 vacant places, and at these 4 vacant places we have to fill up the letters A, I and N. So A has repetition. So this can be done in how many ways? 4 factorial divided by 2 factorial. Why? Because we have repetition of 2 A's. So this is equal to 24 divided by 2, which is 12. So now we are done with the words that are starting with the letter G. Total up till now we have got 24 plus 12, which is equal to 36. Now after G, what comes in the dictionary out of these letters? We will have I. And again we have 4 vacant places. Alright. So again at 4 vacant places we have to arrange. Now I is gone. We have 2 A's, 1 G and 1 N. They can again be arranged in how many ways? 4 factorial divided by 2 factorial. Why? Because of the repetition of 2 A's. So this is again equal to 24 divided by 2, which is equal to 12. Alright, so we are done with all the words in which first letter starts with I. Now we have got 48 24 over here, 12 over here, and 12 over here. So in all, total we have got 48 words. Now after I, the first letter that will be present in the dictionary will be N. We are left with N only because we are done with A, G and I. So we will have as 49th word, the first letter is going to be N, and after N, this place can be occupied by A, and again and A, and then G, and then I. This is the sequence in which a word will be formed in a dictionary. So this will be which word? 49th word. Why? Because above these we have made the calculation of how many words? 48 words. So this is going to be after 48, which means 49th word. And after this word we are going to get our next word, that is 50th word. Let's see what it is. Now N, A, after G we are going to get I, and here we are going to get G. So this is the word which will be present at 50th position of the dictionary, that is NAAIG. The spelling of this word is going to be NAAIG. But since we have been asked the word with or without meaning, so you are not supposed to check out the dictionary and see what is the meaning of this word. Alright, but the answer corresponding to this question is this word. This word is going to occur at 50th position in the dictionary. Alright, I hope everybody must have understood this problem. So this is it for today's lecture. We are done with some beautiful problems that are based on permutations. See you in the next lecture.